Close your eyes and imagine the Earth, not as the blue and green world you know, but as a newborn planet, raw and wild, swirling with fire and chaos. The sun is young and fierce, the sky is dark, and the surface is a landscape of molten rock, volcanoes, and endless bombardment from space. This is the setting for the secret history of Earth's atmosphere, a story that begins not with life, but with violence and transformation. In the earliest days, more than 4.5 billion years ago, Earth was a world in the making. The solar system was a crowded place, filled with dust, gas, and the leftovers of star birth. Planetesimals, small, rocky bodies, collided and merged, growing larger with every impact. Each collision released energy, heating the young planet, melting rock and creating a global ocean of magma. The air was thick with dust and debris, the sky a canvas of fire and stone. The first atmosphere that surrounded Earth was not the air we breathe today. It was a thin, fleeting envelope of hydrogen and helium, the lightest and most abundant elements in the universe, left over from the Big Bang. But this primordial air was doomed from the start. Earth's gravity was not strong enough to hold on to these light gases, especially with the sun's intense radiation and the constant battering of solar wind. In just a few million years, the hydrogen and helium were swept away, lost to space, leaving Earth bare and exposed. But the story did not end there. As the planet cooled, a new atmosphere began to form, born from the heart of the Earth itself. Volcanoes erupted across the surface, spewing out vast clouds of gas, water vapor, carbon dioxide, nitrogen, sulfur compounds, and traces of ammonia and methane. These volcanic gases, released from the molten interior, began to build a new, thicker atmosphere, one that would shape the destiny of the planet. This secondary atmosphere was nothing like the air we know. It was dense and toxic, a choking mix of steam and greenhouse gases. The sky was likely orange or red, filled with clouds of ash and droplets of acid. The surface was still hot, the oceans not yet formed, the land a landscape of lava and chaos. But in this hostile environment, the seeds of the future were being sown. At the same time, Earth was under constant bombardment from space. Asteroids and comets, remnants of the solar system's formation, rained down on the planet, each impact releasing energy, vaporizing rock, and adding new material to the surface and the air. Some of these cosmic visitors brought water, trapped in their icy cores, delivering the first drops that would one day become oceans. Others brought organic molecules, the building blocks of life, mixing with the volcanic gases to create a chemical soup rich in possibility. The combination of volcanic outgassing and cosmic impacts created a dynamic, ever-changing atmosphere. Water vapor condensed to form clouds, and as the planet cooled, rain began to fall. At first in torrents, then in rivers, then in the first shallow seas. The rain washed carbon dioxide from the air, dissolving it in the oceans, beginning the long process of balancing the planet's climate. But the early atmosphere was still a dangerous place. The air was thick with carbon dioxide, making the greenhouse effect strong and the surface hot. There was little or no free oxygen, and the sun's ultraviolet radiation bombarded the surface, unfiltered by an ozone layer. Lightning flashed in the clouds, sparking chemical reactions that created new molecules, new possibilities, new paths for the future. In this world of fire and water, the first steps toward life were being taken. The oceans, rich in dissolved gases and minerals, became a laboratory for chemistry, a place where simple molecules could combine and recombine, forming more complex structures. Some scientists believe that life began in these early seas, sparked by lightning, heated by volcanic vents, nurtured by the energy of the young sun. The primordial atmosphere was not stable. It changed with every eruption, every impact, every shift in the planet's interior. Over millions of years, the balance of gases shifted, the climate cooled, the oceans deepened, and the stage was set for the next great transformation. The rise of life and the slow, patient creation of the air we breathe today. But the memory of the primordial atmosphere remains. It is written in the rocks, in the isotopes of ancient minerals, in the chemistry of the oldest sediments. It is preserved in the airless surfaces of the Moon and Mercury, in the thick, toxic clouds of Venus, in the thin, cold air of Mars. Each world tells a different story, shaped by its own history, its own balance of fire and water, its own dance of creation and destruction. The secret history of Earth's atmosphere is a story of beginnings, a story of violence and renewal, of loss and gain, of the slow, patient work of nature. It is a reminder that the air we breathe is not a given, but a gift, a product of billions of years of change, of the interplay between the planet's interior and the cosmos beyond. As you rest in this gentle night, let yourself imagine the Earth as it was, a world of fire and steam, of volcanic clouds and cosmic rain, of oceans forming and air thickening, of possibility and promise. Picture the volcanoes erupting, the comets falling, the rain pouring down, the first seas rising. Imagine the peace that comes with patience, the beauty that comes with change, the hope that comes with knowing that you are part of a story that is both ancient and ever new. Let yourself wonder what it would be like to stand on the surface of the newborn Earth, to feel the heat of the magma, to breathe the thick alien air, to watch the sky change with every eruption, every impact, every new dawn. Imagine the connection between the air and the land, the water and the sky, the planet and the universe. The primordial atmosphere is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of time to transform everything. Take another breath. Let the story of Earth's first atmosphere fill you with calm. Let the slow, patient journey of the air remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the secret history of the atmosphere, a dreamer in the endless night. Close your eyes and travel back in time, deep into the Hadean Eon, more than 4 billion years ago. The Earth is young, its surface a patchwork of molten rock and cooling crust, its sky thick with volcanic gases and swirling clouds of dust. But this is not a peaceful world. The solar system is still wild, crowded with debris left over from the birth of the planets. Asteroids and comets, icy wanderers and rocky fragments sweep through space, their paths chaotic, their fates uncertain. This is the era of the Great Bombardment, a time when the heavens rained fire, and every impact changed the world below and the air above. The Late Heavy Bombardment, as scientists call it, was a period of intense cosmic violence that lasted for hundreds of millions of years. During this time, Earth and its neighbors were struck again and again by objects ranging from small meteoroids to massive asteroids and comets, some as large as mountains, others as big as small planets. Each collision was an explosion, releasing more energy than all the world's volcanoes combined, vaporizing rock, melting crust, and sending shockwaves through the planet's interior. But the story of the Great Bombardment is not just one of destruction. It is also a story of creation, of transformation, of the slow, patient building of the atmosphere and the oceans. With every impact, new materials were delivered to Earth: water ice from comets, carbon compounds from asteroids, gases trapped in the hearts of ancient bodies. The energy of the impact drove chemical reactions in the air and the seas, creating new molecules, new possibilities, new paths for the future. Imagine a comet, born in the cold outer reaches of the solar system, its heart rich with water ice, carbon dioxide, ammonia, and organic molecules. For millions of years, it drifts in darkness until a chance encounter with a planet or another body sends it hurtling toward the inner solar system. As it approaches the sun, the comet begins to warm, its ice is vaporizing, its tail streaming behind it in a blaze of light. Then, in a final fiery moment, it collides with Earth, releasing its cargo of water and gases into the atmosphere, adding to the growing envelope of air, seeding the planet with the ingredients for life. Asteroids, too, played their part. These rocky bodies, remnants of the building blocks of planets, carried metals, minerals, and volatile compounds. When they struck the Earth, they blasted craters into the surface, melted rock, and released gases trapped in their cores. The impacts vaporized water and carbon dioxide, adding to the steam and greenhouse gases in the air, helping to warm the planet and drive the cycles of rain and evaporation. The Great Bombardment was a time of extremes. The surface of the Earth was constantly reshaped by impacts, its crust broken and remade, its basins filled and emptied. The air was thick with dust and ash, the sky darkened by clouds of debris, the sun often hidden, the climate swinging between hot and cold, wet and dry. But through it all, the atmosphere grew, changing with every collision, evolving from a thin, fleeting envelope to a dense, dynamic system. One of the most important gifts of the Great bombardment was water. The early Earth was hot, its surface molten, its air filled with steam, but as the planet cooled, the water vapor began to condense, forming clouds, then rain, then rivers and lakes, and finally, the first oceans. The impacts of comets and water-rich asteroids added to this process, delivering vast amounts of water to the surface, filling the basins and lowlands, carving valleys and canyons, creating the conditions for life to begin. The rain fell for thousands, perhaps millions of years, washing carbon dioxide from the air, dissolving it into the seas, helping to moderate the planet's temperature. The oceans became a laboratory for chemistry, a place where simple molecules could combine and recombine, forming more complex structures, setting the stage for the first living cells. But the Great Bombardment was not just about water. The impacts also delivered organic molecules, amino acids, sugars, and other building blocks of life. These compounds, formed in the cold of space, survived the fiery passage through the atmosphere and the violence of impact, mixing with the water and minerals on the surface, creating a rich chemical soup. Some scientists believe that life itself may have begun in this crucible, sparked by the energy of impacts, nurtured by the ingredients delivered from space. The evidence for the Great Bombardment is written in the rocks. The oldest surfaces on the Moon, Mercury and Mars are covered in craters, scars from a time when impacts were common and the solar system was a dangerous place. On Earth, most of the evidence has been erased by erosion, plate tectonics, and the endless recycling of the crust. But traces remain in ancient zircons, in the chemistry of the oldest rocks, and the isotopes of noble gases trapped in minerals. The Great Bombardment also shaped the atmosphere in other ways. Each impact released gases from the crust and mantle, adding to the air, changing its composition, driving cycles of warming and cooling. The impacts may have helped create the first greenhouse effect, trapping heat and keeping the planet warm enough for liquid water to exist. They may have also triggered episodes of global cooling, as dust and aerosols block sunlight, plunging the world into darkness and cold. The legacy of the great bombardment is all around us. The oceans, the air, the land, and even life itself bear the marks of this ancient era. The water we drink, the air we breathe, the molecules that make up our bodies, all are in part the gifts of comets and asteroids, the result of collisions that shaped the world and set the stage for everything that followed. As you rest in this gentle night, let yourself imagine the earth as it was during the great bombardment. Picture the sky filled with fireballs, the ground shaking with impacts, the air thick with steam and dust, the rain falling in torrents, the oceans rising, the chemistry of life beginning. Imagine the peace that comes with patience, the beauty that comes with change, the hope that comes with knowing that you are part of a story that is both ancient and ever new. Let yourself wonder what it would be like to witness the birth of the atmosphere, to see the world transformed by fire and water, to feel the connection between the air and the land, the water and the sky, the planet and the universe. The great bombardment is a remindé, that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of time to transform everything. Take another breath. Let the story of Earth's early bombardment fill you with calm. Let the slow, patient journey of the air remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the secret history of the atmosphere, a dreamer in the endless night. Close your eyes and imagine the Earth after the chaos of the great bombardment. The surface is still scarred by impacts, volcanoes still erupt, and the air is thick with steam and gas. But something is changing. The planet is cooling. The relentless rain of asteroids and comets is slowing, and the heat from the young sun is less fierce. The world is ready for a transformation that will turn fire into water, chaos into calm, and a hostile planet into a home for life. In the beginning, Earth's atmosphere was a dense, toxic mix of volcanic gases, water vapor, carbon dioxide, nitrogen, sulfur compounds, and traces of ammonia and methane. The air was hot and heavy, the sky a swirling canvas of clouds and ash. But as the planet cooled, the water vapor in the air began to condense. Clouds thickened, and for the first time, rain began to fall. Not for hours or days, but for thousands, perhaps millions of years. Imagine the sound of that ancient rain falling on hot rock, hissing and steaming, carving channels and valleys, filling to lowlands, and slowly, steadily creating the first rivers, lakes, and seas. The rain was relentless, a deluge that washed over the land, dissolving minerals, carrying nutrients, and shaping the surface of the planet. The water pooled in the deepest basins, forming the primordial oceans, vast, dark, and mysterious, covering much of the earth. The formation of the oceans was a turning point in the history of the atmosphere. As water vapor condensed and fell as rain, the air became thinner, cooler, and less dense. The greenhouse effect, once driven by thick clouds of steam, began to moderate. The temperature dropped, the climate stabilized, and the stage was set for new cycles to begin. But the rain did more than just fill the oceans. It also changed the composition of the air. As water fell from the sky, it dissolved carbon dioxide, carrying it into the seas, where it reacted with minerals to form carbonates, rocks that would lock away carbon for billions of years. This process, known as weathering, helped to regulate the planet's temperature, preventing runaway greenhouse warming and creating a feedback loop that would keep Earth habitable. The oceans became a vast reservoir not just of water but of dissolved gases and minerals. The chemistry of the seas was complex and dynamic, a laboratory for reactions that would one day give rise to life. The water absorbed carbon dioxide, ammonia, and other gases, creating a rich soup of molecules. Lightning, volcanic heat, and ultraviolet light from the sun provided the energy for new compounds to form, amino acids, sugars, and the building blocks of proteins and DNA. The rise of water vapor and the formation of oceans also changed the way the atmosphere interacted with the surface. The oceans acted as a buffer, absorbing heat during the day and releasing it at night, moderating the climate and creating a more stable environment. The water cycle, evaporation, condensation, precipitation, became a global engine, moving energy and matter around the planet, linking the air, the land, and the sea in a single, interconnected system. The presence of liquid water was a miracle, a rare and precious gift in the solar system. On Venus, the greenhouse effect ran wild, boiling away any oceans that might have formed, leaving a world of acid clouds and crushing heat. On Mars, the air was too thin, the temperature too cold, and the water that once flowed on its surface is now locked away as ice. But on Earth, the balance was just right. The oceans endured, the climate stabilized, and the planet became a cradle for life. The rise of water vapor and the formation of oceans also set the stage for the next great transformation, the emergence of life. In the warm, shallow seas, simple molecules combined and recombined, forming more complex structures. Some scientists believe that life began near hydrothermal vents, cracks in the ocean floor where hot mineral-rich water spewed into the sea, creating a rich environment for chemistry. Others suggest that life began in tidal pools, where cycles of wetting and drying concentrated molecules and drove reactions. Wherever it began, life quickly began to change the atmosphere. The first living cells were simple, but they consumed and released gases, altering the balance of the air and the chemistry of the oceans. Over time, life would become the dominant force, shaping the atmosphere, driving cycles of oxygen, carbon, and nitrogen, and creating the conditions for complexity and diversity. But in these early days, the atmosphere was still a world of water vapor, carbon dioxide, and nitrogen. There was little or no free oxygen, and the sun's ultraviolet radiation still bombarded the surface, unfiltered by an ozone layer. The air was thick and heavy, the climate warm and wet, the world a place of storms and rain, of rivers and seas, of possibility and promise. The rise of water vapor and the formation of oceans was a slow, patient process, unfolding over millions of years. It was driven by the cooling of the planet, the condensation of steam, the relentless fall of rain, and the slow, steady accumulation of water in the basins and lowlands. It was shaped by the chemistry of the air, the minerals of the land, the energy of the sun, and the cycles of the planet. As you rest in this gentle night, let yourself imagine the earth as it was during the rise of water vapor. Picture the clouds thickening, the rain falling, the rivers carving valleys, the oceans filling the basins, the air growing cooler and clearer. Imagine the peace that comes with patience, the beauty that comes with change, the hope that comes with knowing that you are part of a story that is both ancient and ever new. Let yourself wonder what it would be like to stand on the shore of the first ocean, to feel the rain on your skin, to breathe the thick, steamy air, to watch the sky change with every storm, every sunrise, every new day. Imagine the connection between the air and the water, the land and the sea, the planet and the universe, the rise of water vapor and the formatio. And of oceans is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of time to transform everything. Take another breath. Let the story of Earth's first oceans fill you with calm. Let the slow, patient journey of the air and water remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the secret history of the atmosphere, a dreamer in the endless night. Close your eyes and imagine the Earth as a newborn world, still glowing with the heat of its formation. The surface is a restless sea of molten rock, volcanoes erupting in every direction, the sky thick with steam and gas. But above this chaos, the very first atmosphere is forming, a thin, fragile veil of hydrogen and helium, the lightest and most abundant elements in the universe. This is Earth's first breath, a fleeting moment in the planet's history, a chapter that would soon be erased by the relentless forces of space and time. Hydrogen and helium are the simplest elements, forged in the first minutes after the Big Bang. They filled the early universe, drifting through space, gathering into clouds, and eventually forming the stars and planets. When Earth was born, it too was surrounded by these light gases captured from the solar nebula held in place by the planet's gravity. For a brief time, Earth's atmosphere was like that of the giant planets, thin, light, and dominated by hydrogen and helium. But this fervent breath was not to last. Earth's gravity, though strong, was not strong enough to hold on to such light gases, especially in the face of the young sun's fierce energy. The sun was more active in its youth, sending out powerful streams of charged particles, the solar wind, that battered the planets, stripping away their atmospheres, blasting the lightest elements into space. The process of atmospheric escape is a dance of energy and motion. At the top of the atmosphere, molecules of hydrogen and helium move at incredible speeds, their energy boosted by the heat of the sun and the collisions of particles. Some of these molecules move fast enough to reach escape velocity, the speed needed to break free from Earth's gravity. Once they reach this threshold, they are lost forever, drifting into the void, never to return. This escape is most efficient for the lightest gases. Hydrogen, the smallest and fastest, is the first to go, followed by helium. Heavier gases, like water vapor, carbon dioxide, nitrogen, and methane, move more slowly, their molecules less likely to reach escape velocity, more likely to be held by gravity. Over millions of years, the hydrogen and helium are stripped away, leaving behind a denser, heavier atmosphere, rich in volcanic gases and the products of chemical reactions. The loss of hydrogen and helium was not just a matter of gravity and heat. It was also driven by the chemistry of the early atmosphere. Hydrogen, in particular, is highly reactive, combining with oxygen to form water, with carbon to form methane, with nitrogen to form ammonia. These compounds are heavier, less likely to escape, more likely to be trapped in the air or dissolved in the ocean. The chemistry of the atmosphere was a filter, a gatekeeper, a process that transformed the air from light and fleeting to dense and enduring. The escape of hydrogen and helium also set the stage for the next chapters in Earth's atmospheric history. With the lightest gases gone, the atmosphere became dominated by water vapor, carbon dioxide, nitrogen, and other volcanic gases. The air grew thicker, the greenhouse effect stronger, the climate warmer. The stage was set for the formation of oceans, the rise of life, the slow, patient transformation of the planet. But the loss of hydrogen and helium was not unique to Earth. It happened on Mars and Venus as well, though with different results. Mars, smaller and colder, lost most of its atmosphere, leaving behind a thin, dry, and cold world. Venus, closer to the Sun, retained a thick atmosphere of carbon dioxide, its surface baked by a runaway greenhouse effect. Only the giant planets, Jupiter, Saturn, Uranus, and Neptune, were massive enough to hold on to their hydrogen and helium, becoming worlds of gas and clouds, their atmospheres deep and mysterious. The story of hydrogen and helium loss is also a story of protection. Earth's magnetic field, generated by the spinning iron core, acts as a shield, deflecting much of the solar wind, protecting the atmosphere from being stripped away entirely. Without this magnetic field, Earth might have ended up like Mars, its air lost to space, its surface barren and lifeless. The first breath of Earth's atmosphere was a fleeting moment, a chapter that lasted only a few million years. But its loss was essential, a necessary step in the evolution of the air, a process that made possible the dense, rich atmosphere that would one day support life. The escape of hydrogen and helium was a kind of purification, a winnowing of the air, a transformation that set the stage for everything that followed. The memory of this first breath is written in the rocks, in the isotopes of noble gases trapped in ancient minerals, in the chemistry of the oldest sediments. It is preserved in the airless surfaces of the Moon and Mercury, in the thick, hydrogen-rich atmospheres of the giant planets, in the thin, dry air of Mars. Each world tells a different story, shaped by its own history, its own balance of gravity and heat, its own dance of creation and loss. As you rest in this gentle night, let yourself imagine the Earth as it was during its first breath. Picture the thin veil of hydrogen and helium, the sun's fierce wind, the molecules racing to escape, the chemistry of the air changing with every reaction, every collision, every new dawn. Imagine the peace that comes with patience, the beauty that comes with change, the hope that comes with knowing that you are part of a story that is both ancient and ever new. Let yourself wonder what it would be like to stand on the surface of the newborn Earth, to feel the lightness of the air, to watch the sky change as the gases escape, to sense the transformation of the planet, the preparation for the next chapter in the history of the atmosphere. The first breath and the loss of hydrogen and helium is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony and connection, in the power of nature to create order from chaos, and in the power of time to transform everything. Take another breath. Let the story of Earth's first breath fill you with calm. Let the slow, patient journey of the air remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the secret history of the atmosphere, a dreamer in the endless night. Close your eyes and imagine the Earth, still young but no longer a world of fire and chaos. The oceans have formed, the rain has fallen, and the air is thick and heavy. But this is not the air you know. There is no oxygen to breathe, no ozone to shield the surface from the sun's harsh rays. Instead, the sky is filled with a cocktail of gases: methane, ammonia, carbon dioxide, and water vapor, a toxic blend that would choke and poison any animal alive today. This is the age of poison, a time when the chemistry of the atmosphere was both a barrier and a bridge to the future. After the loss of hydrogen and helium, Earth's atmosphere was dominated by volcanic gases. Water vapor condensed to form oceans, and carbon dioxide was slowly drawn down by rain and weathering. But other gases remained, and some grew more abundant. Methane, a simple molecule made of carbon and hydrogen, was released by volcanoes and by the chemical reactions in the hot, mineral-rich oceans. Ammonia, a compound of nitrogen and hydrogen, also bubbled up from the depths, its sharp, acrid smell a sign of the planet's restless chemistry. In this world the air was thick and hazy, the sky perhaps tinted orange or green by the scattering of sunlight through clouds of methane and ammonia. The sun was far hotter than it is today, but the greenhouse effect was strong, trapping heat and keeping the planet warm enough for liquid water to persist. The surface was battered by ultraviolet radiation, unfiltered by an ozone layer, and the oceans were rich in dissolved gases and minerals. It was in this hostile environment that the first life began to stir. The earliest cells were simple, fragile, and utterly alien to us. They did not breathe oxygen, for there was none. Instead, they relied on the chemistry of their surroundings, using methane, ammonia, hydrogen, and other molecules as sources of energy and building blocks. Some of these primitive organisms, known as methanogens, thrived in the absence of oxygen, producing methane as a waste product, adding to the haze and the greenhouse effect. The age of poison was a time of slow, patient change. The chemistry of the atmosphere and the chemistry of life were locked in a feedback loop, each shaping the other, each setting the stage for what was to come. The methane and ammonia in the air absorbed sunlight, warming the planet, but they were also broken down by ultraviolet radiation, creating new molecules, new possibilities, new paths for evolution. Lightning flashed in the clouds, sparking chemical reactions that created amino acids, sugars, and other organic compounds. These molecules rained down into the oceans, mixing with the products of volcanic eruptions and cosmic impacts, creating a rich soup of potential. The first cells fed on this soup, using the energy of chemical reactions to grow, divide, and evolve. But the age of poison was not just a time of danger. It was also a time of opportunity. The lack of oxygen meant at the surface was free from the corrosive effects of oxidation, allowing delicate molecules to survive and combine. The abundance of methane and ammonia provided a source of energy for early life, a way to build complexity from simplicity, a path from chemistry to biology. Over millions of years, the atmosphere and the biosphere co-evolved. The first photosynthetic organisms, perhaps purple bacteria or green sulfur bacteria, began to use sunlight to drive chemical reactions, producing food from carbon dioxide and hydrogen sulfide, releasing sulfur or other byproducts into the air. These early photosynthesizers did not produce oxygen, but they paved the way for the next great transformation. The age of poison was also a time of experimentation. The atmosphere was a laboratory, a place where new molecules were created, tested, and sometimes destroyed. The air was filled with haze, the surface bathed in ultraviolet light, the oceans rich in dissolved gases and minerals. Life was fragile, but it was also resilient, adapting to the challenges of its environment, finding new ways to survive and thrive. The evidence for the age of poison is written in the rocks. Ancient sediments contain isotopic signatures of methane and ammonia, clues to the chemistry of the air and the metabolism of early life. The oldest fossils, stromatolites, layered structures built by microbial mats, bear witness to the slow, patient work of life in a world without oxygen. The chemistry of ancient soils, the composition of ancient minerals, the patterns of ancient isotopes, all tell the story of an atmosphere that was once toxic, but also full of promise. The age of poison did not last forever. As life evolved, new forms of metabolism emerged, new ways of using energy, new ways of interacting with the air and the oceans. The stage was set for the next great revolution, the rise of oxygen, the transformation of the atmosphere, the birth of the modern world. But the memory of the age of poison remains. It is preserved in the methane seeps and hydrothermal vents of the deep ocean, in the metabolism of archaea and bacteria, in the chemistry of Titan's atmosphere, in the haze of distant exoplanets. It is a reminder that life can thrive in the most unlikely places, that the air we breathe is the product of billions of years of change, that the history of the atmosphere is a story of danger and opportunity, of barriers and bridges, of patience and possibility. As you rest in this gentle night, let yourself imagine the earth as it was during the age of poison. Picture the thick, hazy air, the orange or green sky, the oceans rich in methane and ammonia, the first cells feeding on chemical energy, the slow, patient transformation of the world. Imagine the peace that comes with patience, the beauty that comes with change, the hope that comes with knowing that you are part of a story that is both ancient and ever new. Let yourself wonder what it would be like to breathe the air of the early earth, to see the sky through a haze of methane, to watch the first life struggle and adapt, to feel the connection between the air and the ocean, the chemistry and the biology, the planet and the universe. The age of poison is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony and connection, in the power of nature to create order from chaos, and in the power of life to transform everything. Take another breath. Let the story of Earth's toxic beginnings fill you with calm. Let the slow, patient journey of the air remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the secret history of the atmosphere, a dreamer in the endless night. Close your eyes and imagine the Earth, still wrapped in a thick toxic shroud of methane, ammonia, and carbon dioxide. The oceans are dark and rich with chemicals, the sky is hazy, and the air is unbreathable. Life exists, but it is simple. Tiny cells, invisible to the naked eye, drifting in the water, feeding on the energy of chemical reactions. But in this world of poison and possibility, a quiet revolution is about to begin. It will be led not by giants, but by the smallest of creatures, cyanobacteria. Cyanobacteria are among the oldest life forms on Earth. Sometimes called blue-green algae, though they are not true algae, these tiny microbes are masters of survival. They thrive in the shallow, sunlit waters of the early oceans, forming mats and colonies, building layered structures called stromatolites. But their true genius lies in their ability to harness the power of sunlight. Through a process called photosynthesis, cyanobacteria use sunlight to convert carbon dioxide and water into food, releasing oxygen as a byproduct. At first, the oxygen produced by cyanobacteria is a poison. The early atmosphere and oceans are full of iron and other elements that react quickly with oxygen, removing it from the air and locking it away in rocks and sediments. For millions of years, the oxygen produced by photosynthesis is absorbed by the environment, leaving the air still thick with methane and carbon dioxide. But the cyanobacteria are patient. They continue to grow, to multiply, to cover the shallow seas in vast green carpets. Over time, the supply of reactive elements is exhausted. The iron in the oceans is oxidized, forming bands of rust-colored rock that will one day be mined as iron ore. The oxygen begins to accumulate, first in the water, then in the air. The world is changing, slowly but surely, molecule by molecule, breath by breath. This transformation is known as the Great Oxygenation Event, a turning point in the history of the planet, a revolution that will make possible the rise of complex life. As oxygen levels rise, the atmosphere is transformed. The methane and ammonia are broken down, replaced by nitrogen and oxygen. The sky clears, the haze fades, and the air becomes transparent and blue. The sun's ultraviolet rays, once deadly, are filtered by a new layer of ozone, created from the oxygen in the air. The surface becomes safer, the climate more stable, the possibilities for life more diverse. But the oxygen revolution is not without its costs. For many of the early life forms, oxygen is a deadly poison. The rise of oxygen triggers a mass extinction, wiping out countless species that cannot adapt to the new chemistry. But for others, oxygen is an opportunity, a new source of energy, a new way to grow, a new path to complexity. The stage is set for the evolution of eukaryotes, multicellular organisms, plants, animals, and eventually humans. The Evi. Dense for the cyanobacteria revolution is written in the rocks. Ancient stromatolites, some more than 3.5 billion years old, bear witness to the slow, patient work of these microbes. The banded iron formations, found on every continent, are a record of the oxygenation of the oceans, the rusting of the world, the transformation of the air. The isotopes of sulfur and carbon in ancient sediments tell the story of changing chemistry, of the rise and fall of gases, of the interplay between life and the environment. Cyanobacteria are still with us today. They thrive in lakes, ponds, and oceans, forming blooms that can be seen from space. They are the ancestors of the chloroplasts in plants, the tiny factories that power photosynthesis in every leaf, every blade of grass, every tree. The oxygen we breathe, the food we eat, the energy that sustains us, all are gifts from these ancient microbes, the quiet revolutionaries who changed the world. The cyanobacteria revolution is a story of patience, of persistence, of the power of the small to change the fate of the great. It is a reminder that the most profound transformations often begin in silence, in the invisible work of countless individuals, in the slow accumulation of change over time. As you rest in this gentle night, let yourself imagine the world as it was before oxygen. Picture the dark, hazy sky, the greenish seas, the simple cells drifting in the water. Then imagine the first cyanobacteria, harnessing sunlight, releasing oxygen, changing the chemistry of the world. Imagine the slow, patient rise of oxygen, the transformation of the air, the clearing of the sky, the birth of a new world. Let yourself wonder what it would like to witness the cyanobacteria revolution, to see the oceans turn blue, the sky become clear, the air become breathable. Imagine the connection between the smallest of creatures and the greatest of changes, the power of life to shape the planet, the beauty of patience and persistence. The cyanobacteria revolution is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of life to transform everything. Take another breath. Let the story of the cyanobacteria revolution fill you with calm. Let the slow, patient journey of the air remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the secret history of the atmosphere, a dreamer in the endless night. Close your eyes and imagine the world as it was more than 2 billion years ago. The oceans are deep and green, the sky is still hazy, and the air is thick with nitrogen, carbon dioxide, and traces of methane. Life exists, but it is simple. Tiny cells drifting in the water, feeding on sunlight and chemical energy, building the first fragile webs of ecology. But something is happening, quietly and patiently, that will change the world forever. Oxygen, once a rare and deadly poison, is beginning to fill the air. This is the great oxygenation event, a revolution that will transform the planet, the atmosphere, and the future of life. The story begins with the cyanobacteria, the tiny microbes that learn to harness the power of sunlight through photosynthesis. For millions of years they released oxygen as a byproduct, but the oceans and rocks absorbed it as fast as it was made. Iron in the water rusted and sank to the sea floor, forming banded iron formations that still mark the rocks today. Sulfur and other elements reacted with oxygen, locking it away in minerals and sediments. The air remained anoxic, the world unchanged. But the cyanobacteria were patient. They continued to grow, to multiply, to cover the shallow seas in vast green mats. Over time, the supply of reactive elements was exhausted. The iron in the oceans was used up, the sulfur was locked away, and the oxygen began to accumulate, first in the water, then in the air. The world was changing molecule by molecule, breath by breath. At first, the rise of oxygen was slow, almost imperceptible, but as the balance tipped, the pace quickened. Oxygen began to build up in the atmosphere, reaching levels that were toxic to many of the life forms that had evolved in its absence. For these organisms, oxygen was a deadly poison, destroying their cells, disrupting their chemistry, driving them to extinction, or forcing them to retreat to the few remaining anoxic environments. But for others, oxygen was an opportunity. Some microbes evolved new ways to use oxygen, harnessing its power to extract more energy from food, to grow larger, to become more complex. The rise of oxygen made possible the evolution of eukaryotes, cells with nuclei and organelles, the ancestors of all plants, animals, and fungi. It set the stage for the explosion of life that would follow, for the rise of multicellularity, for the birth of the modern world. The great oxygenation event was not just a biological revolution, it was a planetary transformation. As oxygen filled the air, the chemistry of the atmosphere changed. Methane, a powerful greenhouse gas, was broken down by oxygen, causing the planet to cool. Some scientists believe that this cooling triggered the first snowball Earth events, global ice ages that covered the planet in glaciers, challenging life to adapt and evolve. Oxygen also led to the formation of the ozone layer, a thin shield of O3 high in the atmosphere that absorbs the sun's deadly ultraviolet rays. With the ozone layer in place, life could move from the oceans to the land, colonizing new environments, diversifying into new forms, exploring new possibilities. The evidence for the great oxygenation event is written in the rocks. Banded iron formations found on every continent are a record of the rusting of the oceans, the removal of iron by oxygen, the transformation of the planet's chemistry. The isotopes of sulfur and carbon in ancient sediments tell the story of changing gases, of the rise and fall of oxygen, of the interplay between life and the environment. The oldest red beds, rocks stained with iron oxide, mark the first appearance of oxygen in the air, the beginning of a new era. The great oxygenation event was not a single moment, but a process that unfolded over hundreds of millions of years. Oxygen levels rose and fell, the climate swung between hot and cold, life adapted and evolved. But the trend was clear. The world was becoming more oxygen-rich, more complex, more full of possibility. The rise of oxygen was both a blessing and a curse. It made possible the evolution of complex life, the explosion of diversity, the colonization of new environments. But it also caused mass extinctions, drove many organisms to extinction, and triggered global climate changes. The story of oxygen is a story of transformation, of opportunity and challenge, of the power of life to shape the planet. Today, oxygen makes up about 21% of Earth's atmosphere. It is the gas we breathe, the fuel for our cells, the foundation of our metabolism. It is produced by plants and algae, recycled by animals and microbes, balanced by the cycles of the biosphere. The air we breathe is a gift from the past, a legacy of the cyanobacteria and the great oxygenation event. A reminder that the atmosphere is not just a backdrop, but a living, changing system. As you rest in this gentle night, let yourself imagine the world as it was during the great oxygenation event. Picture the oceans turning blue, the sky becoming clear, the air filling with oxygen, the first eukaryotes evolving, the first multicellular life emerging. Imagine the peace that comes with patience, the beauty that comes with change, the hope that comes with knowing that you are part of a story that is both ancient and ever new. Let yourself wonder what it would be like to witness the rise of oxygen, to see the world transformed by a single molecule, to feel the connection between the air and the ocean, the chemistry and the biology, the planet and the universe. The great oxygenation event is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of life to transform everything. Take another breath. Let the story of oxygen's rise fill you with calm. Let the slow, patient journey of the air remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the secret history of the atmosphere, a dreamer in the endless night. Close your eyes and imagine the Earth as a world transformed. Oceans frozen from pole to pole, continents buried beneath miles of ice, the sky pale and cold, the air thin and biting. This is not a vision of some distant alien planet, but of our own world during one of its most dramatic chapters, the era of Snowball Earth. It was a time when the atmosphere and climate danced a dangerous waltz, when changes in the air triggered global catastrophes, and when life itself was pushed to the brink only to emerge stronger and more diverse than ever before. The story of Snowball Earth begins with the rise of oxygen, as cyanobacteria and other photosynthetic organisms filled the air with this new reactive gas. The chemistry of the atmosphere changed. Methane, a powerful greenhouse gas that had helped keep the planet warm, was broken down by oxygen, replaced by carbon dioxide and nitrogen. The greenhouse effect weakened, and the planet began to cool. Over millions of years, the temperature dropped, glaciers advanced, and the first great ice ages began. But these were no ordinary ice ages. During the most extreme episodes, known as Snowball Earth events, the ice spread from the poles to the equator, covering nearly the entire planet in a frozen shell. The oceans were capped with ice up to a kilometer thick, the continents buried beneath glaciers, the air filled with fine, icy dust. The sun's light reflected off the white surface, cooling the planet even further, creating a feedback loop that made escape from the deep freeze nearly impossible. How could such a catastrophe happen? The answer lies in the delicate balance between the atmosphere, the oceans, and the climate. When the greenhouse effect is strong, the planet is warm and wet, with rain and rivers, forests and life. But if the greenhouse gases are removed, by weathering, by the burial of organic carbon, by the rise of oxygen, the balance tips and the world cools. If the cooling is strong enough, ice begins to spread, reflecting more sunlight, driving temperatures even lower. The result is a runaway ice age, a snowball Earth. The evidence for these global glaciations is written in the rocks. Ancient sediments, found on every continent, show signs of glacial activity near the equator. Scratched and polished stones, dropstones in marine mud, layers of till and outwash. These rocks are capped by layers of carbonate, deposited when the ice melted and the oceans became saturated with carbon dioxide. The isotopes of carbon and oxygen in these rocks tell the story of a world that froze, then thawed, then froze again. But Snowball Earth was not just a time of cold, it was also a time of darkness, of famine, of mass extinction. The ice cut off the oceans from the air, starving the water of oxygen, killing off many forms of life. Photosynthesis slowed or stopped, as sunlight could not penetrate the thick ice. Only the hardiest organisms survived. Microbes living near hydrothermal vents, algae in thin cracks in the ice, bacteria in brine pockets and hot springs. Life was pushed to the edge, but it endured, adapting to the harshest conditions, waiting for the world to change, and change it did. The same processes that triggered the ice ages eventually brought them to an end. As volcanoes continued to erupt, they released carbon dioxide into the air, but with the oceans frozen, there was no way for the gas to be removed. Over millions of years, carbon dioxide built up to levels hundreds of times higher than today, creating a supercharged greenhouse effect. When the ice finally began to melt, it did so rapidly, in a series of catastrophic floods and storms. The oceans became hot and acidic, the air thick with carbon dioxide, the climate swinging from one extreme to another. But from this chaos came renewal. The melting of the ice released nutrients into the oceans, fueling blooms of algae and bacteria, sparking a burst of evolution and diversification. The end of Snowball Earth is closely linked to the rise of complex life, the first animals, the first multicellular organisms, the first steps toward the Cambrian explosion. The atmosphere, once a barrier, became a bridge, connecting the cycles of geology, chemistry, and biology in a new and powerful way. Snowball Earth was not the only time when changes in the atmosphere triggered global catastrophes. Throughout Earth's history, volcanic eruptions, asteroid impacts, and shifts in the carbon cycle have caused mass extinctions, wiping out entire branches of the tree of life. The end Permian extinction, 252 million years ago, was triggered by massive volcanic eruptions in Siberia, which released huge amounts of carbon dioxide and methane, warming the planet, acidifying the oceans, and killing more than 90% of all species. The end Cretaceous extinction, 66 million years ago, was caused by an asteroid impact that filled the air with dust and soot, blocking sunlight, cooling the planet, and ending the age of the dinosaurs. Each of these catastrophes was a turning point, a moment when the atmosphere and the climate conspired to reshape the world. Each was a test of life's resilience, a challenge that forced evolution to find new paths, new forms, new possibilities. Each was a reminder that the air we breathe is not a given, but a gift, a product of billions of years of change, of the interplay between the planet's interior and the cosmos beyond. As you rest in this gentle night, let yourself imagine the Earth as it was during Snowball Earth. Picture the frozen oceans, the white continents, the pale sky, the air thin and cold. Imagine the silence, the darkness, the struggle for survival, the hope that comes with patience, the beauty that comes with change. Imagine the world thawing, the ice melting, the oceans blooming with life, the atmosphere transformed, the future unfolding. Let yourself wonder what it would be like to witness a global catastrophe, to see the world freeze and thaw, to feel the connection between the air and the land, the water and the sky, the planet and the universe. Snowball Earth and climate catastrophes are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of life to adapt, survive, and flourish. Take another breath. Let the story of Earth's great ice ages fill you with calm. Let the slow, patient journey of the air remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the secret history of the atmosphere, a dreamer in the endless night. Close your eyes and imagine the Earth, transformed by the great oxygenation event. The air is no longer thick with methane and ammonia, but fresh with oxygen, the sky a clear blue, the oceans alive with new forms of life. But the sun, ever powerful, still sends its ultraviolet rays streaming toward the surface. Rays that can damage DNA, disrupt cells, and threaten the fragile beginnings of complex life. In this world, a new protector is about to emerge, born from the very oxygen that now fills the air, the ozone layer. The story of the ozone layer begins with the rise of oxygen. As cyanobacteria and other photosynthetic organisms filled the atmosphere with this reactive gas, a new kind of chemistry became possible. High in the stratosphere, where the air is thin and the sun's rays are strong, ultraviolet light began to break apart oxygen molecules, O2, splitting them into individual oxygen atoms. These atoms, highly reactive, quickly combined with other O2 molecules to form ozone, O3, a rare and remarkable molecule capable of absorbing the sun's most dangerous radiation. The formation of the ozone layer was a slow, patient process, unfolding over millions of years as oxygen levels in the atmosphere rose. At first the layer was thin, patchy, and fragile, but as more oxygen accumulated, the ozone layer thickened, creating a shield that would change the fate of life on Earth. The ozone layer is not a solid wall, but a diffuse band of gas, stretching from about 15 to 35 kilometers above the surface, its concentration highest in the lower stratosphere. The importance of the ozone layer cannot be overstated. Before its emergence, the surface of the Earth was bombarded by ultraviolet UV radiation, a form of light that is invisible to our eyes but deadly to living cells. UV rays can break the bonds in DNA, causing mutations, cancer, and death. For billions of years, life was confined to the oceans, where water provided protection from the sun's harshest rays. Only with the rise of the ozone layer did it become possible for life to move onto land, to colonize new environments, to evolve into the rich diversity we see today. The ozone layer acts as a filter, absorbing more than 97% of the sun's harmful UVB and UVC radiation. It allows just enough UVA to reach the surface to drive important chemical reactions, but not so much as to threaten life. The presence of the ozone layer is a delicate balance, maintained by the constant interplay of sunlight, oxygen, and atmospheric chemistry. The emergence of the ozone layer was a turning point in the history of the atmosphere. It marked the beginning of a new era, when the surface of the earth became a safe haven for life, when plants and animals could thrive in the open air, when evolution could explore new forms and new possibilities. The ozone layer is a gift from the past, a legacy of the cyanobacteria and the great oxygenation event, a reminder that the air we breathe is not just a backdrop, but a living, changing system. But the ozone layer is also a lesson in vulnerability. It is thin, fragile, and easily damaged by human activity. In the late 20th century, scientists discovered that certain chemicals, chlorofluorocarbons, CFCs, used in refrigeration, air conditioning, and aerosols, were breaking down ozone in the stratosphere, creating a hole over Antarctica and thinning the layer worldwide. The loss of ozone led to increased UV radiation at the surface, raising the risk of skin cancer, cataracts, and harm to plants and animals. The discovery of the ozone hole was a wake-up call, a reminder that the atmosphere is a shared resource, a system that connects all life on Earth. In response, nations around the world came together to sign the Montreal Protocol, an international agreement to phase out the use of ozone-depleting chemicals. The protocol has been a success, and the ozone layer is slowly recovering, a testament to the power of science, cooperation, and hope. The story of the ozone layer is a story of connection between the chemistry of the air, the energy of the sun, and the fate of life. It is a reminder that the atmosphere is still a passive envelope, but an active participant in the story of the planet. The ozone layer is a bridge between the past and the future, a shield that protects, a sign of the power of nature to adapt and endure. As you rest in this gentle night, let yourself imagine the emergence of the ozone layer. Picture the sun's rays streaming toward the earth, the oxygen molecules splitting and recombining, the ozone forming high above, the shield growing stronger with every breath of life. Imagine the first plants and animals venturing onto land, protected by the invisible barrier, exploring new worlds, evolving into new forms. Let yourself wonder what it would be like to live in a world without an ozone layer, to feel the sun's rays unfiltered, to see the sky through a haze of UV light, to witness the struggle of life to survive in a hostile environment. Imagine the peace that comes with protection, the beauty that comes with balance, the hope that comes with knowing that you are part of a story that is both ancient and ever new. The ozone layer is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of life to transform everything. Take another breath. Let the story of the ozone layer fill you with calm. Let the slow, patient journey of the air remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the secret history of the atmosphere, a dreamer in the endless night. Close your eyes and imagine the Earth, its surface cooling after the chaos of bombardment and the rise of oxygen. The air is still thick with carbon dioxide, the oceans deep and restless, the land a patchwork of volcanic mountains and rocky plains. But beneath the surface, a new dance is beginning, a dance of carbon, a cycle that will shape the climate, the chemistry, and the future of life. This is the story of the carbon cycle, a quiet, patient process that balances the air, connects the land and sea, and links the living and the non-living in a web of exchange. The carbon cycle is the great regulator of Earth's atmosphere. It is the reason our planet is not a frozen wasteland like Mars or a runaway oven like Venus. It is the process that keeps carbon dioxide, the main greenhouse gas of the early Earth, in balance, preventing the planet from overheating or freezing, creating a climate where life can thrive. The story begins with volcanoes. For billions of years, volcanoes have been the planet's breath, releasing carbon dioxide, water vapor, and other gases from the deep interior into the air. Every eruption is a reminder that the Earth is alive, its core hot and dynamic, its surface shaped by the slow, patient movement of tectonic plates. The carbon dioxide released by volcanoes is a powerful greenhouse gas, trapping heat and warming the planet, keeping the oceans liquid and the climate stable. But the carbon dioxide does not stay in the air forever. As rain falls, it dissolves carbon dioxide, forming a weak acid that seeps into the soil and flows into rivers and streams. This acid rain reacts with rocks, breaking them down in a process called weathering. The products of this reaction, calcium, magnesium, and bicarbonate ions, are carried to the oceans, where they combine to form carbonate minerals, locking away carbon in the form of limestone and other rocks. This process is slow but relentless. Over millions of years, weathering removes carbon dioxide from the air, balancing the input from volcanoes, keeping the climate in check. The carbon locked in rocks can remain there for hundreds of millions of years, until tectonic forces push the rocks deep into the earth, where they are melted and recycled, releasing carbon dioxide back into the air through new volcanic eruptions. But the carbon cycle is not just a geological process. Life, too, plays a crucial role. Plants, algae, and cyanobacteria use photosynthesis to capture carbon dioxide from the air and turn it into food, releasing oxygen as a byproduct. Animals eat the plants, using the carbon to build their bodies, and release carbon dioxide back into the air through respiration. When plants and animals die, their remains are buried. Some of the carbon locked away in sediments, some return to the air through decay. The oceans are a key part of the carbon cycle. They absorb carbon dioxide from the air, store it in the water, and use it to build the shells and skeletons of countless marine organisms. When these creatures die, their shells sink to the sea floor, becoming part of the sediments, locking away carbon for millions of years. The ocean is both a sink and a source of carbon, a buffer that helps stabilize the atmosphere, a reservoir that connects the air, the water, and the living world. The carbon cycle is a system of checks and balances, a feedback loop that keeps the planet climate within the bounds needed for life. If carbon dioxide levels rise, the planet warms, weathering increases, and more carbon is removed from the air. If carbon dioxide levels fall, the planet cools, weathering slows, and volcanoes add more carbon to the atmosphere. The result is a dynamic equilibrium, a balance that has persisted for billions of years, allowing life to flourish and evolve. But the carbon cycle is also a story of change. Over Earth's history, the balance has shifted, sometimes slowly, sometimes suddenly. Ice ages have come and gone, triggered by changes in the carbon cycle, by the movement of continents, by the rise and fall of mountains, by the evolution of new forms of life. Mass extinctions have been linked to disruptions in the carbon cycle, volcanic eruptions that filled the air with carbon dioxide, asteroid impacts that blocked the sun and cooled the planet, the burial or release of vast amounts of organic carbon. The carbon cycle is also a story of connection. It links the air and the land, the water and the rocks, the living and the non-living. Every breath you take, every meal you eat, every stone you touch is part of this cycle, a participant in the endless exchange of carbon that shapes the world. The carbon in your body was once part of the air, the ocean, the rocks. the plants and animals that lived and died before you. The cycle is a reminder that we are all connected, that the boundaries between self and world, life and non-life, are fluid and ever-changing. Today, the carbon cycle is under pressure. Human activities, burning fossil fuels, cutting forests, changing the land, are adding carbon dioxide to the air faster than the natural processes can remove it. The balance is tipping, the climate is warming, the oceans are acidifying, the future is uncertain. But the carbon cycle endures, adapting to new conditions, finding new paths, offering hope that balance can be restored. As you rest in this gentle night, let yourself imagine the dance of the carbon cycle. Picture the volcanoes erupting, the rain falling, the rivers flowing, the rocks weathering, the oceans absorbing, the plants growing, the animals breathing, the sediments forming, the cycle turning. Imagine the peace that comes with balance, the beauty that comes with connection, the hope that comes with knowing that you are part of a story that is both ancient and ever new. Let yourself wonder what it would be like to witness the birth of the carbon cycle, to see the first rains fall, the first rivers carve valleys, the first plants grow, the first animals breathe. Imagine the connection between the air and the land, the water and the rocks, the living and the non-living, the planet and the universe. The beginning of the carbon cycle is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of life and geology to shape the fate of the world. Take another breath. Let the story of the carbon cycle fill you with calm. Let the slow, patient journey of the air and the rocks remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the secret history of the atmosphere, a dreamer in the endless night. Close your eyes and imagine walking through a forest, but not the kind you know today. The air is thick and humid. The trees are ancient ferns and towering horsetails, their fronds arching overhead to form a green cathedral. The ground is soft with moss and fallen leaves, and the air is alive with the hum and rustle of countless creatures. But as you look closer, you realize something astonishing. The insects are enormous. Dragonflies with wingspans as wide as a hawksbill idle through the air. Millipedes as long as a car coil through the undergrowth. Spiders the size of dinner plates spin webs between the trunks. This is the age of giant insects, a time when the atmosphere was rich with oxygen, and life on land reached new and extraordinary forms. The story of giant insects begins in the late Paleozoic era, about 300 million years ago, during the Carboniferous and early Permian periods. The world was different then. Vast swamps and forests covered much of the land, filled with towering lycopsids, seed ferns, and early conifers. The climate was warm and wet, and the air was thick with oxygen, much more than today. Scientists estimate that oxygen levels reached as high as 35%, compared to the 21% we breathe now. Why was there so much oxygen? The answer lies in the carbon cycle and the rise of land plants. As forests spread across the continents, photosynthesis pulled carbon dioxide from the air and released oxygen as a byproduct. At the same time, the dead plants fell into the swamps and were buried, locking away carbon in the form of peat and eventually coal. With less carbon dioxide and more oxygen, the atmosphere became supercharged, creating conditions that would never be repeated. This oxygen-rich air had profound effects on life. Insects, unlike mammals or birds, do not have lungs. They breathe through a network of tiny tubes called tracheae, which deliver oxygen directly to their tissues. The size of an insect is limited by how efficiently oxygen can diffuse through these tubes. In today's atmosphere, this limits most insects to a few centimeters in length, but in the high oxygen world of the Carboniferous, diffusion was much more efficient, and insects could grow to enormous sizes. The fossil record is filled with the remains of these giants. Meganeura, a dragonfly-like insect, had a wingspan of more than 70 centimeters, over 2 feet. Arthropleura, a millipede relative, reached lengths of more than 2 meters, over 6 feet, making it the largest land invertebrate ever known. Giant cockroaches, scorpions, and spiders prowled the forests, their size limited only by the abundance of oxygen and the strength of their exoskeletons. But the age of giant insects was not just a time of monsters. It was also a time of innovation and adaptation. The high oxygen levels allowed for more active lifestyles, faster growth, and greater diversity. Insects became the first animals to fly, their wings evolving from extensions of the exoskeleton. Their bodies adapted for gliding, hovering, and darting through the air. The forests echoed with the buzz and whir of wings, the rustle of legs, the click of mandibles. The presence of giant insects also shaped the evolution of other life forms. Early amphibians and reptiles had to contend with these formidable predators and competitors, driving the evolution of new defenses, new behaviors, new ways of living. The balance of power in the ecosystem was different, the rules of the game set by the chemistry of the air. But the age of giant insects did not last forever. As the Carboniferous gave way to the Permian, the climate changed. The continents drifted together, forming the supercontinent Pangaea. The swamps dried up, the forests retreated, and the burial of plant material slowed. Oxygen levels began to fall, returning to more modern values. The giant insects, unable to get enough oxygen to support their massive bodies, dwindled and disappeared, replaced by smaller, more efficient forms. The end of the age of giant insects was also marked by mass extinctions driven by changes in climate, sea level, and atmospheric composition. The Permian-Triassic extinction, 252 million years ago, wiped out more than 90% of all species, clearing the way for the rise of dinosaurs, mammals, and the modern world. But the memory of the age of giant insects remains. It is written in the rocks, in the fossils of dragonflies and millipedes, in the coal beds that fuel our power plants, in the chemistry of the air we breathe. It is a reminder that the atmosphere is not just a backdrop, but a driver of evolution, a force that shapes the possibilities of life. Today, insects are much smaller, but they are still among the most successful and diverse animals on Earth. Their ability to adapt, to exploit new environments, to evolve new forms and behaviors, is a testament to the power of life to endure and thrive. The air we breathe is less rich in oxygen, but it is still the product of billions of years of change, of the interplay between life and the environment, of the dance of the atmosphere. As you rest in this gentle night, let yourself imagine the world as it was during the age of giant insects. Picture the towering forests, the thick, humid air, the dragonflies gliding overhead, the millipedes coiling through the undergrowth, the spiders spinning webs between ancient trees. Imagine the peace that comes with patience, the beauty that comes with change, the hope that comes with knowing that you are part of a story that is both ancient and ever new. Let yourself wonder what it would be like to walk through those ancient forests, to see the world through the eyes of a giant insect, to feel the connection between the air and the land, the life and the atmosphere, the past and the present. The age of giant insects is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of life to adapt, flourish, and transform the world. Take another breath. Let the story of Earth's ancient air fill you with calm. Let the slow, patient journey of the atmosphere remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the secret history of the atmosphere, a dreamer in the endless night. Close your eyes and imagine the Earth as it was hundreds of millions of years ago. The land is mostly barren, a world of rock and sand with only the occasional patch of moss or lichen clinging to the damp ground. The air is thick with carbon dioxide, the climate warm and humid, the sky often shrouded in clouds. But something is about to change, a quiet green revolution that will transform the planet, the atmosphere, and the future of life. This is the story of the rise of land plants, a chapter in Earth's history when forests and ferns began to breathe, and the air itself was forever altered. The first plants to colonize the land were small and simple, mosses, liverworts, and hornworts, their bodies low and flat, their lives tied to water. They crept across the damp soil, spreading slowly, anchoring themselves with tiny root-like structures, absorbing nutrients and moisture from the ground. These pioneers were fragile, but they paved the way for something greater. Over millions of years, plants evolved new ways to survive on land. They developed true roots to anchor themselves and draw water from deeper in the soil. They grew stems and leaves to reach for the sun, to capture more light, to photosynthesize more efficiently. They developed waxy coatings to prevent drying out, and vascular tissues to transport water and nutrients throughout their bodies. The first ferns, horsetails, and club mosses appeared, their fronds arching above the ground, their spores drifting on the wind. As plants spread across the continents, they began to change the air. Through photosynthesis, they pulled carbon dioxide from the atmosphere and released oxygen as a byproduct. The forests grew dense and tall, their canopies shading the ground, their roots breaking up the rock, their leaves falling to form thick layers of peat and soil. The carbon that had once filled the air was now locked away in the bodies of plants, in the soil, in the growing beds of coal that would one day fuel the fires of industry. The impact on the climate was profound. As carbon dioxide levels fell, the greenhouse effect weakened, and the planet began to cool. The spread of forests helped stabilize the climate, moderating temperatures, increasing rainfall, and creating new habitats for animals and other life forms. The air became richer in oxygen, the sky clearer, the world more hospitable to life. The rise of land plants also transformed the water cycle. Forests, Indi ferns drew water from the soil and released it into the air through transpiration, creating clouds, driving rainfall, and shaping the patterns of rivers and lakes. The land became greener, wetter, and more diverse. A patchwork of forests, swamps, and meadows, each with its own community of plants and animals. The forests of the Carboniferous period, about 300 million years ago, were among the most remarkable in Earth's history. Towering like copsids, some more than 30 meters tall, formed dense, swampy jungles. Giant ferns and horsetails grew in the understory, their fronds creating a green cathedral. The air was thick with oxygen, the climate warm and humid, the world alive with insects, amphibians, and the first reptiles. These ancient forests were not just beautiful, they were engines of change. As plants died and fell into the swamps, they were buried and compressed, forming vast beds of peat and eventually coal. This process locked away even more carbon, further reducing greenhouse gases, cooling the planet, and setting the stage for the next great ice ages. The rise of land plants was also a revolution in evolution. The new habitats created by forests allowed animals to diversify and adapt, leading to the rise of insects, amphibians, and the first land-dwelling vertebrates. The roots of plants stabilize the soil, preventing erosion, and their leaves and stems provided food and shelter for countless species. The web of life grew more complex, more interconnected, more resilient. But the story of the rise of land plants is also a story of feedback and balance. As plants pulled carbon dioxide from the air, the climate cooled, and ice ages came and went. The burial of organic matter in coal beds reduced the amount of carbon available for photosynthesis, slowing the growth of forests and stabilizing the atmosphere. The cycles of growth and decay, of burial and release, of photosynthesis and respiration created a dynamic equilibrium that has persisted for hundreds of millions of years. The evidence for the rise of land plants is written in the rocks, fossilized spores and pollen, the remains of ancient forests, the layers of coal and peat, the isotopes of carbon and oxygen, all tell the story of a world transformed by green. The chemistry of the air, the patterns of rainfall, the diversity of life, all bear the marks of this quiet revolution. Today, plants continue to shape the atmosphere and the climate. Forests and grasslands absorb carbon dioxide, release oxygen, and moderate the temperature. The loss of forests through deforestation and climate change threatens this balance, reminding us that the air we breathe is not a given, but a gift, a product of billions of years of evolution, of the interplay between life and the environment. As you rest in this gentle night, let yourself imagine the world as it was during the rise of land plants. Picture the first mosses creeping across the rocks, the ferns and horsetails reaching for the sun, the forests spreading across the continents, the air growing clearer, the climate cooling, the world becoming green and alive. Imagine the peace that comes with patience, the beauty that comes with change, the hope that comes with knowing that you are part of a story that is both ancient and ever new. Let yourself wonder what it would be like to walk through those ancient forests, to breathe the oxygen-rich air, to see the world through the eyes of a dragonfly or a giant millipede, to feel the connection between the air and the land, the plants and the animals, the past and the present. The rise of land plants is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of life to transform everything. Take another breath. Let the story of Earth's green revolution fill you with calm. Let the slow, patient journey of the air and the forests remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the discrete history of the atmosphere. Close your eyes and imagine the Earth as a world in constant motion, its surface alive with volcanoes, its skies sometimes darkened by ash, its history marked by sudden catastrophic change. The atmosphere, so often a gentle blanket of air, can also be a stage for drama, a place where the forces of nature and the cosmos conspire to reset the balance of life. This is the story of mass extinctions and atmospheric shocks, a tale of how volcanic eruptions and asteroid impacts have, time and again, transformed the air, the climate, and the very course of evolution. Throughout Earth's long history, life has flourished and diversified, filling every niche, adapting to every challenge. But this progress has not been smooth. There have been moments, rare but profound, when the world was shaken to its core, when the atmosphere itself became a we upon, and when most living things perished in a geological instant. These are the mass extinctions, the punctuation marks in the story of life, the times when the air became a harbinger of death and eventually a cradle for renewal. One of the most dramatic agents of atmospheric change is volcanism. When a supervolcano erupts, it can release vast amounts of ash, sulfur dioxide, and carbon dioxide into the air. The ash can block sunlight, plunging the world into darkness, cooling the climate, and disrupting photosynthesis. The sulfur dioxide forms aerosols, tiny droplets that reflect sunlight and further cool the planet. The result can be a volcanic winter, a period of years or even decades when temperatures drop, crops fail, and ecosystems collapse. But volcanoes also release carbon dioxide, a greenhouse gas that can over longer timescales warm the planet, melt ice, and drive climate change. The balance between cooling and warming, between ash and gas, is delicate and complex. Sometimes the effects are local and short-lived, but at other times they are global and catastrophic. The Permian-Triassic extinction about 252 million years ago was the most severe in Earth's history. More than 90% of all marine species and 70% of terrestrial species vanished. The cause? Massive volcanic eruptions in what is now Siberia, which released trillions of tons of carbon dioxide and other gases, warming the planet, acidifying the oceans, and poisoning the air. The atmosphere became a crucible, a place where life was tested, and for many found wanting. Asteroid impacts are another source of atmospheric shock. When a large asteroid strikes the Earth, it releases energy equivalent to millions of nuclear bombs, vaporizing rock, igniting fires, and sending dust and debris high into the atmosphere. The most famous of these impacts occurred 66 million years ago, at the end of the Cretaceous period. A 10-kilometer-wide asteroid struck what is now the Yucatan Peninsula, creating the Chicxulub crater and triggering the extinction of the dinosaurs. The impact released a cloud of dust and soot that blocked sunlight, plunging the world into darkness and cold. Photosynthesis stopped, food chains collapsed, and more than 75% of all species disappeared. The atmosphere became a weapon, a barrier to life, a force of destruction. But in the aftermath, the survivors, mammals, birds, and others, found new opportunities, new niches, new paths to evolution. These mass extinctions were not just biological events, they were atmospheric revolutions. The composition of the air changed, sometimes rapidly, sometimes over thousands of years. Oxygen levels dropped or rose, carbon dioxide spiked or fell, temperatures swung between extremes. The air became a record of catastrophe, a memory of loss, a promise of renewal. But the atmosphere is also resilient. After each shock, the cycles of air and water, of carbon and oxygen, of life and death, resumed. Volcanoes and weathering, photosynthesis and respiration, burial and uplift, all work together to restore balance, to create new climates, to set the stage for the next chapter in the story of life. The evidence for these atmospheric shocks is written in the rocks. Layers of ash and soot, spikes in iridium and sulfur, changes in isotopes and fossils, all tell the story of a world transformed by catastrophe. The rocks are a record of darkness and light, of death and rebirth, of the power of the air to shape the fate of life. But mass extinctions and atmospheric shocks are not just stories of the past. They are warnings for the present and the future. Human activity, burning fossil fuels, releasing greenhouse gases, altering the land, has begun to change the atmosphere in ways that echo the great catastrophes of the past. The air is warming, the climate is shifting, the balance is tipping. The lessons of history are clear. The atmosphere is both fragile and powerful, both a gift and a responsibility. As you rest in this gentle night, let yourself imagine the world during a mass extinction. Picture the sky darkened by ash, the air thick with dust, the sun a faint glow, the land and sea quiet and still. Imagine the silence, the loss, the hope that comes with survival, the beauty that comes with renewal. Imagine the connection between the air and the land, the life and the atmosphere, the past and the future. Let yourself wonder what it would be like to witness a volcanic winter, to see the world change in an instant, to feel the power of the atmosphere to destroy and to heal. Imagine the peace that comes with patience, the beauty that comes with change, the hope that comes with knowing that you are part of a story that is both ancient and ever new. Mass extinctions and atmospheric shocks are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony and connection, in the power of nature to create order from chaos, and in the power of life to adapt, survive, and flourish. Take another breath. Let the story of Earth's great catastrophes fill you with calm. Let the slow, patient journey of the air remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the secret history of the atmosphere, a dreamer in the endless night. Close your eyes and imagine the world after the chaos of mass extinctions, after the reign of the dinosaurs has ended, after the atmosphere has weathered storms of fire, ice, and darkness. The air is clearing, the climate is stabilizing, and a new era is dawning. This is the age of mammals, a time when the atmosphere finds a new balance, when the world becomes more familiar, and when the stage is set for the rise of humanity. The end of the Cretaceous, 66 million years ago, was a turning point. The asteroid impact that wiped out the dinosaurs also cleared the way for mammals, small, warm-blooded, and adaptable, to diversify and thrive. The atmosphere, once choked with dust and soot, gradually cleared as sunlight returned, plants regrew, and the cycles of air and water resumed. Oxygen levels stabilized, carbon dioxide found a new equilibrium, and the climate settled into a pattern of warm and cool periods, ice ages and interglacials that would shape the future of life. During the Paleogene and Neogene periods, forests spread across the continents, grasslands emerged, and mammals evolved into an astonishing variety of forms. Giant ground sloths, saber-toothed cats, woolly mammoths, and, eventually, the first primates. The air was rich enough in oxygen to support large, active animals, but not so rich as to fuel the fires and insects of the Carboniferous. The balance of gases was maintained by the interplay of volcanoes, weathering, photosynthesis, and respiration, a dynamic equilibrium that kept the planet habitable. The atmosphere also played a crucial role in shaping the climate. The rise of the Himalayas and the Andes, the opening and closing of ocean gateways, the waxing and waning of ice sheets, all influenced the flow of air and water, the distribution of heat, the patterns of rainfall and drought, the cycles of carbon and oxygen, of nitrogen and water, of dust and aerosols, all work together to create a world of diversity and change. It was in this world that the first hominins, our distant ancestors, emerged in Africa. The climate was variable, swinging between wet and dry, forest and savanna, challenging life to adapt, to innovate, to explore new ways of living. The air was clear and breathable. The sun's rays filtered by a healthy ozone layer, the seasons marked by the tilt of the earth and the dance of the atmosphere. As mammals evolved, so did their relationship with the air. The development of endothermy, warm-bloodedness, allowed mammals to thrive in a wide range of environments, to be active at night and in the cold, to colonize every continent and habitat. The lungs of mammals became more efficient, the exchange of oxygen and carbon dioxide more finely tuned, the connection between life and air more intimate than ever before. The atmosphere also shaped the evolution of plants, which in turn shaped the air. The spread of grasses created vast savannas, supporting herds of grazing animals and the predators that hunted them. The rise of flowering plants diversified the food supply, supporting insects, birds, and mammals in a web of life that grew ever more complex. The air was filled with pollen and spores, with the scents of flowers and the songs of birds, with the breath of life in every corner of the world. The cycles of the atmosphere became the cycles of life, the monsoons and trade winds, the jet streams and ocean currents, the El Niño and La Niña events, all influenced the distribution of rain and drought, of heat and cold, of abundance and scarcity. The air became a carrier of seeds and spores, of dust and nutrients, of signals and scents. The atmosphere was not just a backdrop, but a participant in the story of evolution. As the age of mammals unfolded, the climate continued to change. Ice ages came and went. Glaciers advanced and retreated, sea levels rose and fell. The air grew colder and drier, then warmer and wetter, in cycles driven by the tilt and orbit of the earth, by the feedbacks of ice and water, by the slow, patient dance of the atmosphere. These changes challenged life to adapt, to migrate, to evolve new forms and behaviors. It was in this world of change and challenge that humans emerged. Our ancestors learned to walk upright, to use tools, to make fire, to build shelters, to communicate and cooperate. They learned to read the signs in the air, the coming of rain, the approach of storms, the changing of the seasons. The atmosphere became a source of knowledge, a guide to survival, a partner in the journey of life. With the rise of agriculture, humans began to shape the atmosphere in new ways. The clearing of forests, the planting of crops, the domestication of animals, all altered the balance of gases, the flow of carbon and nitrogen, the cycles of water and dust. The air became a record of human activity, a mirror of our choices, a measure of our impact on the world. The age of mammals and the stabilization of the atmosphere set the stage for the modern world. The air we breathe today is the product of billions of years of change, of the interplay between life and the environment, of the dance of volcanoes, weathering, photosynthesis, and evolution. It is a gift from the past, a legacy of patience and resilience, a reminder that the atmosphere is both fragile and enduring. As you rest in this gentle night, let yourself imagine the world as it was during the age of mammals. Picture the forests and grasslands, the herds of animals, the changing seasons, the clear, breathable air. Imagine the peace that comes with balance, the beauty that comes with diversity, the hope that comes with knowing that you are part of a story that is both ancient and ever new. Let yourself wonder what it would be like to witness the rise of mammals, to breathe the air of a world in balance, to see the connection between the atmosphere, the evolution of life, the past and the present, the land and the sky. The age of mammals and the stabilization of the atmosphere is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony and connection, in the power of nature to create order from chaos, and in the power of life to adapt, flourish, and transform the world. Take another breath. Let the story of Earth's modern air fill you with calm. Let the slow, patient journey of the atmosphere remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the secret history of the atmosphere, a dreamer in the endless night. Close your eyes and imagine the air you breathe. It is invisible, weightless, and yet it is everywhere, filling your lungs, carrying the scent of rain, the warmth of the sun, the coolness of night. For billions of years, the atmosphere has been shaped by volcanoes, oceans, forests, and the slow, patient work of life. But in the blink of an eye, just a few centuries, humans have become the atmosphere's newest architects, leaving a mark that is both profound and unmistakable. This is the story of the human footprint, a chapter in the secret history of Earth's air that is still being written. The story begins with the rise of agriculture. 10,000 years ago, humans learned to plant seeds, to tend crops, to domesticate animals. The forests were cleared, the grasslands plowed, the wetlands drained. The land was transformed, and with it, the air. The burning of wood and brush released carbon dioxide. The cultivation of rice paddies and the raising of livestock released methane. And the clearing of forests reduced the planet's ability to absorb carbon. The atmosphere began to change, slowly at first, then more rapidly as human populations grew and spread. With the dawn of the Industrial Revolution, the pace of change accelerated. Coal, oil, and natural gas, fossil fuels formed from the remains of ancient plants and animals, became the engines of progress. Factories, trains, ships, and later cars and airplanes all burned these fuels, releasing vast amounts of carbon dioxide, sulfur dioxide, nitrogen oxides, and other gases into the air. The sky over cities darkened with soot and smoke. The air filled with the acrid tang of pollution. The climate began to shift. The invention of new chemicals brought new challenges. Chlorofluorocarbons, CFCs, used in refrigeration and aerosols, drifted into the stratosphere where they broke down the ozone layer, allowing more ultraviolet radiation to reach the surface. Leaded gasoline poisoned the air and the soil, harming children and wildlife. Pesticides and fertilizers carried by the wind altered the chemistry of the atmosphere and the health of ecosystems. The human footprint on the atmosphere is not just a matter of pollution, it is also a matter of scale. In just a few centuries, humans have released more carbon dioxide than volcanoes emit in millions of years. The concentration of carbon dioxide in the air has risen from about 280 parts per million before the Industrial Revolution to over 420 parts per million today, a level not seen in millions of years. Methane and nitrous oxide, both powerful greenhouse gases, have also increased dramatically, driven by agriculture, industry, and waste. The consequences of these changes are everywhere. The climate is warming, the ice is melting, the seas are rising. Heat waves, droughts, floods, and storms are becoming more frequent and severe. The air in many cities is unhealthy to breathe, filled with fine particles and toxic gases. The oceans are acidifying, the forests are burning, the balance of the atmosphere is tipping. But the human footprint is not just a story of harm. It is also a story of awareness, of action, of hope. Scientists have measured the changes in the atmosphere, traced the sources of pollution, modeled the impacts of greenhouse gases, and warned of the dangers ahead. Citizens have demanded cleaner air, safer water, and a healthier planet. Governments have passed laws to limit emissions, to protect the ozone layer, to reduce acid rain, to encourage renewable energy and conservation. The story of the ozone hole is a lesson in both danger and hope. When scientists discovered that CFCs were destroying the ozone layer, the world responded. The Montreal Protocol, signed in 1987, phased out the use of ozone-depleting chemicals. The ozone layer is now healing, a testament to the power of science, cooperation, and the will to change. The story of air pollution is similar. In the 20th century, smog choked cities from London to Los Angeles, killing thousands and darkening the sky. But clean air laws, new technologies, and public pressure have reduced pollution, improved health, and restored blue skies to many places. The air is still not perfect, but it is better than it was, a sign that progress is possible. The challenge of climate change is the greatest test yet. The atmosphere is warming, the weather is changing, and the future is uncertain. But the tools to address the problem are at hand: renewable energy, energy efficiency, reforestation, carbon capture, and new ways of living and working. The choices we make today will shape the air for generations to come, determining whether the atmosphere remains a gift or becomes a burden. The human footprint on the atmosphere is a reminder that we are both powerful and vulnerable, both creators and destroyers, both part of nature and apart from it. The air we breathe is a record of our history, a mirror of our choices, a measure of our responsibility. It is a reminder that the atmosphere is not just a backdrop, but a living, changing system shaped by every breath, every fire, every field, every factory. As you rest in this gentle night, let yourself imagine the air as it was, as it is, and as it could be. Picture the forests and fields, the cities and factories, the winds and clouds, the cycles of carbon and oxygen, the dance of molecules and light. Imagine the peace that comes with balance, the beauty that comes with awareness, the hope that comes with knowing that you are part of a story that is both ancient and ever new. Let yourself wonder what it would be like to breathe the air of the past, to see the sky through the eyes of a mammoth or a mastodon, to witness the changes brought by fire and plow, by steam and smoke, by invention and ambition. Imagine the connection between the air and the land, the life and the atmosphere, the past and the future. The human footprint on the atmosphere is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony and connection, in the power of nature to create order from chaos, and in the power of people to shape the world for better or worse. Take another breath. Let the story of Earth's changing air fill you with calm. Let the slow, patient journey of the atmosphere remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the secret history of the atmos. Fear, a dreamer in the endless night. Close your eyes and imagine the Earth as a delicate blue marble, floating in the vastness of space. The sun's rays travel across millions of kilometers, bathing the planet in warmth and light. Some of this energy is reflected back into space by clouds and ice, but much of it is absorbed by the land and oceans, heating the surface and making life possible. But the story does not end there. The Earth, in turn, radiates energy back towards space in the form of invisible infrared light. And here, in the thin layer of air that surrounds the planet, a quiet miracle occurs, a process that keeps the world from freezing, that shapes the climate, that connects the air, the land, and the sea. This is the greenhouse effect. The greenhouse effect is the reason Earth is habitable. Without it, the average temperature of the planet would be about -18 degrees Celsius, 0 degrees Fahrenheit. Too cold for liquid water, too cold for life as we know it. But thanks to certain gases in the atmosphere, carbon dioxide, methane, water vapor, nitrous oxide, and ozone, much of the outgoing infrared radiation is absorbed and re-emitted, trapping heat and keeping the surface warm. These greenhouse gases act like the glass of a greenhouse, letting sunlight in but slowing the escape of heat, creating a stable, life-friendly climate. For most of Earth's history, the greenhouse effect has been a force for balance. The levels of greenhouse gases have risen and fallen with the cycles of volcanoes, weathering, photosynthesis, and respiration. When the planet cooled, carbon dioxide built up, warming the air and melting the ice. When the planet warmed, weathering and plant growth drew down carbon dioxide, cooling the air and restoring balance. The result was a dynamic equilibrium, a climate that could swing between ice ages and warm periods, but always returned to a state where life could thrive. But the greenhouse effect is also a force for change. When the balance is disturbed, by massive volcanic eruptions, by the burial or release of organic carbon, by the rise of new forms of life, the climate can shift dramatically. The snowball Earth events, the Permian and Cretaceous extinctions, the rise and fall of ancient forests, all were shaped by changes in greenhouse gases, by the dance of carbon and heat. In the last few centuries, humans have become a new force in this dance. By burning fossil fuels, coal, oil, and natural gas, we have released vast amounts of carbon dioxide into the air, increasing its concentration by more than 50% since the Industrial Revolution. By clearing forests, draining wetlands, and raising livestock, we have added methane and nitrous oxide, both far more potent than carbon dioxide at trapping heat. The result is a rapid, unprecedented increase in the greenhouse effect, a warming of the planet that is already changing the climate in ways both subtle and dramatic. The science of global warming is clear. As greenhouse gases build up in the atmosphere, more heat is trapped, and the average temperature of the planet rises. The effects are everywhere. Glaciers and ice sheets are melting. Sea levels are rising. Heat waves and droughts are becoming more frequent. Storms are growing more intense. And ecosystems are shifting in response. The air is changing, and with it, the world. But the greenhouse effect is not just a story of danger. It is also a story of connection, a feedback of the intricate web that links the air, the land, the water, and life itself. As the planet warms, the oceans absorb more heat, expanding and rising. The melting of ice reduces the planet's reflectivity, causing more sunlight to be absorbed and accelerating the warming. The thawing of permafrost releases methane, amplifying the greenhouse effect in a feedback loop that can be difficult to stop. Yet the atmosphere is also resilient. Plants and oceans absorb some of the excess carbon dioxide, slowing the pace of change. New technologies and choices, renewable energy, reforestation, energy efficiency, offer hope for restoring balance, for reducing emissions, for healing the air. The story of the greenhouse effect is not just a warning, but a call to action, a reminder that the atmosphere is both a gift and a responsibility. The greenhouse effect is also a source of wonder. It is a reminder that the air we breathe is not just a backdrop, but a living, changing system shaped by the interplay of sunlight, chemistry, and life. The same process that keeps the planet warm can, if unbalanced, drive it to extremes. The same gases that make life possible can, in excess, threaten the future. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of people to shape the world for better or worse. As you rest in this gentle night, let yourself imagine the greenhouse effect at work. Picture the sun's rays streaming toward the earth, warming the land and sea, the air absorbing and re-emitting heat, the balance of energy that keeps the world alive. Imagine the changes that come with imbalance, the warming air, the melting ice, the rising seas, the shifting winds and rains. Imagine the hope that comes with action, the beauty that comes with balance, the peace that comes with knowing that you are part of a story that is both ancient and ever new. Let yourself wonder what it would be like to live in a world without a greenhouse effect, to feel the cold of space, the fragility of life, the importance of every breath, every tree, every choice. Imagine the connection between the air and the land, the water and the sky, the past and the future. The greenhouse effect and global warming are reminders that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony and connection, in the power of nature to create order from chaos, and in the power of life to transform everything. Take another breath. Let the story of Earth's warming air fill you with calm. Let the slow, patient journey of the atmosphere remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the secret history of the atmosphere, a dreamer in the endless night. Close your eyes and imagine the sky above you, a vast invisible shield high in the stratosphere, quietly protecting all life below. This is the ozone layer, a thin band of gas that absorbs the sun's most dangerous ultraviolet rays, making Earth's surface safe for plants, animals, and people. For millions of years, this shield has endured, built molecule by molecule from the oxygen in the air. But in the last century, a new 3T emerged, not from volcanoes or asteroids, but from human hands. This is the story of the ozone hole and recovery, a tale of danger, discovery, and hope, and a lesson in how global action can heal the air. The ozone layer is a marvel of chemistry. High above the clouds, ultraviolet light from the sun splits oxygen molecules, O2, into individual atoms. These atoms quickly combine with other O2 molecules to form ozone, O3. Ozone, in turn, absorbs more ultraviolet light, breaking apart and reforming in a continuous cycle. This dance of creation and destruction keeps the ozone layer in balance, filtering out more than 97% of the sun's harmful UVB and UVC radiation. For most of Earth's history, the ozone layer has been stable, its thickness varying with the seasons and the latitude, but always present, always protective. But in the 20th century, humans invented a new class of chemicals, chlorofluorocarbons, CFCs, used in refrigeration, air conditioning, aerosol sprays, and foam production. CFCs were hailed as a miracle, non-toxic, non-flammable, and stable. But it was their very stability that made them dangerous. When CFCs are released into the air, they drift upward, eventually reaching the stratosphere. There, ultraviolet light breaks them apart, releasing chlorine atoms. These chlorine atoms are highly reactive, and they begin to destroy ozone molecules in a chain reaction. One chlorine atom can destroy thousands of ozone molecules before it is removed from the atmosphere. The result is a thinning of the ozone layer, especially over the polar regions, where cold temperatures and unique atmospheric conditions accelerate the process. In the 1980s, scientists made a startling discovery. Using satellites and ground-based instruments, they found that the ozone layer over Antarctica was disappearing each spring, creating a vast ozone hole that grew larger every year. The loss of ozone meant that more ultraviolet radiation was reaching the surface, increasing the risk of skin cancer, cataracts, and harm to plants and animals. The news shocked the world, and the search for a solution began. The story of the ozone hole is also a story of science and cooperation. Researchers from around the globe work together to understand the chemistry of the atmosphere, to measure the extent of the damage, to trace the sources of the problem. Their work revealed the link between CFCs and ozone depletion and showed that the problem was global, not local, a threat to all life on Earth. The response was swift and unprecedented. In 1987, nations came together to sign the Montreal Protocol, an international agreement to phase out the production and use of ozone-depleting substances. The protocol was a triumph of diplomacy and science, a recognition that the atmosphere is a shared resource, a system that connects all people and all life. Over the years, the protocol has been strengthened and expanded, and today the use of CFCs and similar chemicals has been almost entirely eliminated. The results have been remarkable. The ozone layer is healing. Satellite measurements show that the ozone hole is shrinking, that the thickness of the layer is increasing, that the air is recovering. The Montreal Protocol is often called the most successful environmental treaty in history, a proof that global problems can be solved with global action, that science and policy can work together, that hope is not in vain. But the story is not over. The ozone layer is still fragile, still vulnerable to new threats. Some replacement chemicals, like hydrofluorocarbons, HFCs, do not harm ozone but are powerful greenhouse gases, contributing to global warming. Illegal production and use of banned substances still occurs in some places. The recovery of the ozone layer is a slow process, expected to take until the middle of the 21st century to return to pre-1980 levels. The ozone hole and its recovery are a lesson in humility and responsibility. They remind us that the atmosphere is not just a backdrop, but a living, changing system shaped by every action, every choice, every molecule released into the air. They show that human activity can have unintended and far-reaching consequences, but also that knowledge, cooperation, and determination can heal the damage and restore balance. As you rest in this gentle night, let yourself imagine the ozone layer as a shield high above the earth, quietly absorbing the sun's ultraviolet rays, protecting all life below. Picture the molecules of ozone forming and breaking, the dance of chemistry and light, the balance of creation and destruction. Imagine the threat posed by CFCs, the thinning of the layer, the danger to life, the response of science and policy, the healing that is now underway. Let yourself wonder what it would be like to live in a world without an ozone layer, to feel the sun's rays unfiltered, to see the sky through a haze of UV light, to witness the struggle of life to survive in a hostile environment. Imagine the peace that comes with protection, the beauty that comes with balance, the hope that comes with knowing that you are part of a story that is both ancient and ever new. The ozone hole and its recovery are a reminder that every world has its place. Every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of people to heal what has been harmed. Take another breath. Let the story of the ozone layer fill you with calm. Let the slow, patient journey of the air remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the secret history of the atmosphere. a dreamer in the endless night. Close your eyes and take a slow, deep breath. Feel the air fill your lungs, cool and invisible, nourishing every cell in your body. Now let your mind drift outward, following that breath as it mingles with the world, as it joins the endless cycle of wind and weather, as it becomes part of the great, invisible ocean of air that surrounds the earth. This is the story of air and life, a story of connection, of memory, of the quiet miracle that links every living thing to the planet's past and future. The air you breathe is ancient. Every molecule of oxygen, nitrogen, and carbon dioxide has been part of countless cycles, exhaled by animals, inhaled by plants, dissolved in oceans, released by volcanoes, carried by winds, and shaped by the chemistry of life. The oxygen in your breath was made by photosynthetic organisms, plants, algae, and cyanobacteria, using sunlight to split water and release O2 into the air. The carbon dioxide you exhale was once part of a leaf, a tree, a blade of grass, a drop of ocean water, a cloud in the sky. With every breath, you are connected to the history of the atmosphere. The air you inhale may contain atoms that were once breathed by dinosaurs, by ancient forests, by the first humans who walked the savannas of Africa. The nitrogen in the air was forged in the hearts of stars, scattered across the galaxy by supernovae gathered into the Earth's atmosphere over billions of years. The argon in your breath is a relic of radioactive decay, a silent witness to the planet's deep time. But the connection between air and life is not just a matter of chemistry. It is a matter of cycles, of feedback, of the intricate web that links every living thing to the planet and to each other. Plants take in carbon dioxide and release oxygen. Animals do the reverse. Microbes in the soil and the sea transform nitrogen, making it available to plants and through them to all life. The air is a medium of exchange, a carrier of signals, a bridge between the living and the non-living. The atmosphere is also a record of change. The composition of the air has shifted over time, shaped by the rise and fall of forests, the evolution of new forms of life, the cycles of ice ages and warm periods, the impact of volcanoes and asteroids, and most recently the actions of humans. The air is a mirror of the planet's history, a memory of its triumphs and catastrophes, a measure of its resilience and fragility. The connection between air and life is also a source of wonder. The air is invisible, yet it is everywhere, touching everything, linking every breath to every leaf, every wave, every cloud. The air carries the scent of flowers, the song of birds, the warmth of the sun, the coolness of rain. It is the medium of sound, the carrier of pollen and spores, the stage for the dance of insects and birds. The air is also a source of inspiration. Poets and artists have long celebrated the wind, the sky, the breath of life. The air is a symbol of freedom, of movement, of possibility. It is the space in which we dream, the element that lifts us in flight, the substance that fills our lungs and gives us voice. But the connection between air and life is also a responsibility. The air is fragile, easily changed, easily harmed. Pollution, deforestation, and climate change threaten the balance of gases, the cycles of carbon and nitrogen, the health of ecosystems and people. The air we breathe today is not the same as it was a century ago, and the choices we make now will shape the air for generations to come. The story of air and life is a story of hope. The atmosphere is resilient, capable of healing, of adapting, of supporting life in all its diversity. The cycles of air and water, of carbon and oxygen, of nitrogen and energy, are self-correcting, self-renewing, self-sustaining, if given the chance. The air is a gift, a legacy, a promise that life can endure, that the planet can recover, that the future can be bright. As you rest in this gentle night, let yourself imagine the air as a living, breathing system. Picture the forests and oceans, the winds and clouds, the cycles of photosynthesis and respiration, the dance of molecules and energy. Imagine the peace that comes with connection, the beauty that comes with balance, the hope that comes with knowing that you are part of a story that is both ancient and ever new. Let yourself wonder what it would be like to see the world through the eyes of the air, to drift with the wind, to rise with the clouds, to fall with the rain, to nourish every leaf and every lung. Imagine the connection between the air and the land, the water and the sky, the past and the future. The invisible connection between air and life is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of life to transform everything. Take another breath. Let the story of Earth's living air fill you with calm. Let the slow, patient journey of the atmosphere remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the secret history of the atmosphere, a dreamer in the endless night. Close your eyes and imagine the air above you, not just as the familiar breath in your lungs, but as a vast, layered ocean of invisible currents, swirling molecules, and hidden forces. For all that we have learned about Earth's atmosphere, for all the science and satellites, the measurements and models, there are still mysteries that linger in the sky. The air is full of secrets, questions that have yet to be answered, puzzles that remind us how much there is still to discover. This is the story of atmospheric mysteries, the unsolved questions that keep scientists looking up, wondering and dreaming. One of the greatest mysteries is the origin and fate of certain trace gases. We know that the atmosphere is mostly nitrogen and oxygen, with smaller amounts of argon, carbon dioxide, and water vapor. But there are also hundreds of other gases: methane, nitrous oxide, ozone, and a host of organic compounds, each with its own sources, sinks, and cycles. Some, like methane, are rising faster than we can explain, their sources and sinks shifting with climate, land use, and unknown feedbacks. Others, like certain halocarbons, persist in the air for decades or centuries, their long-term impact still uncertain. The chemistry of the upper atmosphere is another puzzle. High above the clouds, in the stratosphere and mesosphere, sunlight and cosmic rays break apart molecules, creating a complex web of reactions that produce and destroy ozone, form new particles, and influence the climate. The details of these processes, how they change with solar activity, with volcanic eruptions, with human pollution, are still being unraveled. The formation and behavior of noctilucent clouds, the highest clouds in the atmosphere, remain a mystery, their shimmering blue-white forms appearing only in the summer twilight. Their origins linked to both natural and human-made changes. The dynamics of the atmosphere are also full of surprises. The jet streams, fast-moving rivers of air that circle the globe, shift and meander in ways that are not fully understood, influencing weather, climate, and the movement of storms. The sudden stratospheric warmings that can disrupt winter weather, the formation of blocking highs and persistent droughts, the patterns of monsoons and El Niño events, all are subjects of ongoing research, their causes and consequences still being explored. The interaction between the atmosphere and the biosphere is another frontier. We know that forests, oceans, and soils exchange gases with the air, But the details of these exchanges, the role of microbes, the impact of drought and fire, the feedbacks between plants and climate, are still being mapped. The atmosphere is a living system shaped by the breath of trees, the decay of leaves, the bloom of plankton, the migrations of animals. The full complexity of these connections is only beginning to be understood. The atmosphere's role in the planet's energy balance is also a source of mystery. Clouds, for example, are both a shield and a blanket, reflecting sunlight back to space, but also trapping heat and warming the surface. The net effect of clouds on climate is one of the biggest uncertainties in predicting future warming. The formation of